Good morning, everybody. When this SSMB requested me to deliver a lecture on steel, I thought that most of the people, they will discuss on steel consumption, because there is always a fight between the concrete industry and the steel industry. Now, if we choose a particular material, whether it is steel or concrete, if it is chosen judiciously, means it's not that for somebody's benefit, but it is appropriate for that particular application, then probably you will find that not in our country, in US or in Britain, or in other countries, or European countries, in most of the situations, they are choosing steel. Now, the question is very simple, that you can easily understand that whenever we are going for any tall structure, or it's not a conventional structure, a difficult structure, or you can say that, that vibration-prone structures, then we always think about the ductility. And naturally, the amount of ductility or this, whatever ductility provides by steel, that cannot be compared with concrete. Even if you make concrete with the best possible technology, material, and also from the point of view of the detailing, you can achieve, but you can't compare with steel. So that is one of the reasons that people are going for steel. The other thing is that, which I will show you, I will show you three different situations where we have used fully steel. There is no other choice. And I'll try to impress upon you that in most of the difficult situations, means when the connection detail is very difficult, or something is to be done very fast, like my previous speaker told. In all those situations, there is no other way out. We have to go for steel. So with this, let me discuss about this, the work which we have done, because these are the consultancy project which Jadavpur University undertakes, and that's why I have chosen these projects. Yes, so these are the projects which we recently done. One is 52-meter sitting Buddha in Bangla, Sikkim, and the other one is 23-meter long, 22-meter high. This is a polo player on a particular horse, right? And that is in Manipur, under construction. And this is a stadium in Guwahati. This is also a cricket stadium, and this is retrofitting of a earthquake damaged market. It was a RCC market, and then we have retrofitted with steel, structural steel, and the TV tower for Doordarshan, tall towers, and the 80-meter span and 26-meter high hangar in airports. These are all the projects. I would like to share with you that it is done by Jadavpur University fully. It is not that something people may think that somebody has done it, we have signed it. No, it's a total project. Jadavpur University has done, and it's a total estimate, everything done. So that is why I want to project that, because you should know the background of this university now, not like before. Now, you see this particular project, it's a dream project of the then Chief Minister of Manipur, and it is on the top of a hillock, a small hill, and they made a road, and we have constructed, that is also a part of this project, That is a 3-storied museum. And on top of that, this particular statue will be constructed. So you can easily understand that at that particular height, you have to take all these materials and then you have to erect it. So it's a very difficult job. It's very difficult. And there is no other choice than steel. Steel is the only choice. Now this is the kind of horse, you have to erect there. And on top of that, there will be a rider, a polo player with stick. Now, if you see the sections, 1, 1, 2, 2, like that, 16, 16, these are the sections I'll show you. The sections are like this. So we have detailed the sections first to have the anatomy of the horse. That was a great challenge because this kind of thing, they have taken photograph and ultimately they gave us a 3D things, with full of dots, lakhs of dots. And we have to rather, first visualize the skeleton of the horse and the rider, which fits in within this particular, the digital view they have given. And after that, we analyzed it against wind, earthquake, and other forces, and designed it. So this was basically the idea. This is, that basically that when you are connecting one with another, is a particular, in this belly portion, it's like that. So this is the rider part. So that is also, it was like that in digital form, and then we have converted to this. Another thing I have to show you that this retrofitting, which we did in Manipur, a market, and after your earthquake occurred, the government was under tremendous pressure. And just after that, there was election. And naturally, the Chief Minister requested that something should be done immediately. And immediately means, somebody said that you demolish it and announce a new structure. No, that is not at all acceptable because to demolish it is huge amount of money will be required, and then construct it, who will give you the money and all. And at that point of time, I was there, and after discussion, we finalized that yes, it will be done by using structural steel, and it will be retrofitted. And ultimately, it will be, according to IS 1893 and other relevant codes. So no, don't worry about it. So this was the basement of the market. There was 2 markets, and this is the first floor level. It is like this. And you see, these are the columns we retrofitted. These are the columns we have retrofitted, right, with steel, structural steel. And then the steel members are also added. So ultimately, it became a totally a steel building. Because after, using steel, because we have not really destroyed everything which made of concrete, because some columns are not there, not at all. Some portion collapsed, some stair, huge cracks. So what we did actually, we just repaired it, rather rehabilitated it, and just using steel, because we didn't have time. We have to complete the project within 6 months. So with concrete it's impossible. So these are the, basically the column retrofitting. So what it has done, from the basement level, we introduced the base plate like this. One is like this, the C-type base plate, and finally it is butt welded. And then, we have used the steel angles with battens, and before that, the circular shape is given to a square shape. And this is the first stage of construction. In the second stage, and at that particular time, we have used bolts for the base plates, right? And there's a huge raft at the base, very thick raft. So we have drilled, and ultimately, we have inserted the bolts there. And for the frame beams, we have used this particular, structural member, Tata's box section. So, and we have used shear connectors there also, like this, and this. And then we have used some, tie members at the base level because it was not safe. When we analyzed the building, we found that it was not at all safe. So we made it safe. And then, ultimately, this, we have given a skin concrete. We have given a skin concrete because there's a market. Naturally, it is very difficult to maintain steel there, painting, this, that. Maybe a problem, so government requested me to put a skin concrete. And now the market is finished, and they could complete within 8 months. Total project, they have completed within 8 months. So that is about this. And another thing I want to show, that this is a cricket stadium in Guwahati, BCCI. And the stadium is like this, one part of it. This is 1/4 of it. And the other view is like this. So the story behind it, that they proposed concrete structure for this particular stadium. But when we are going for pre-engineered steel structure, then we are getting a lot of advantages. So when we discussed with those companies, ultimately we found that we are not only saving time, but we are also saving huge money. And that is why we opted for steel, because the design was finalized, everything, even the contractor was selected with concrete structure. But ultimately I could convince them that if we go for steel, we will not only saving time, we are also saving money. So that was basically the idea, and it was a pre-engineered structure. It is done in some other state, and then transported to that particular place, and only erected there. So, and even then it is, very cheap. And this was basically this beam layout of that particular stadium. And this was basically, you can't see really, a column detail, right? And this is a raker beam, typical, how it's very difficult to construct with concrete and all. So these are the raker beams. So with this, what I really want to tell you all that there is no fight between steel and concrete. Steel has got definitely some advantage. Concrete has also got some advantage. But only thing is that in a particular situation, you have to take a right decision. Not only from the point of time, also from the point of view of cost and use also. Thank you very much.